Today we're going to continue looking at subatomic structure in an atom, particularly in the electron cloud, how electrons arrange themselves in the electron cloud. Today we're going to look at electron configurations, which are a kind of condensation of sorts of the orbital notations we looked at in our last lesson. Alright, so yesterday we started talking about orbital notation, and today we're going to take that orbital notation and learn to write what are called electron configurations. And by the end of this period then, you will have the information that you need to be able to do almost all, if not all, of the things you need for your element cube. Okay? So I hope you've been working on your element cube. I hope you've been doing the background research and you've been putting that on your element cubes and it's on your flash drive, so that when we finish with electron configurations and ion symbols, you'll be all set to print it out, cut it out, paste it up, and be ready to put it on the board outside on the periodic table that I have out there. And remember, do not come in here expecting to use glue from me. Have it pasted up and dry before you come in here, because I don't want wet glue out there on that periodic table board. No, whenever I tell you. So yesterday we learned from doing the notes that you use the periodic table to figure out orbital notation. And we said that the periodic table can be outlined in a way that shows you where the s orbital region, the p orbital region, d orbital region, and f orbital region are located. These regions do not tell you where electrons are found. These tell you something about how to figure out where electrons are found. The electrons are actually found in primary energy levels and sublevels and orbitals like these S and P orbitals we have illustrated here. Okay? So the primary levels of energy correspond to the energy of the electrons as you drew them when you were in physical science, where you have just 2 electrons in the first primary level, up to 8 in the second, up to 18 in the third, and so forth. And those correspond to where these elements are on the periodic table. Okay? In addition to that, what we've been learning about is the S and P and D sublevel regions also correspond to regions on the periodic table. So by finding an element on the periodic table, we can figure out what the orbital notation is for each element. Now these orbital notations are for what are called ground state electrons. That means the electrons are in their least energy state, their weakest energy state. They don't have any extra energy, so they want to be as close to the nucleus as they can be, and that's why they arrange themselves in this arrangement here with orbitals and primary energy levels and so forth. Because electrons having the same charge want to fly apart, but we can get 2 of them together because we can have opposite spins, which cancels the electromagnetic repulsion that wants to make them fly apart. And so when we did the orbital notations, they looked like this. Okay? And so I gave you 2 homework problems. That's what we're going to look at now. Homework problem number 1 was for orbital notation for phosphorus, and the other one was for orbital notation for nickel. So if you'll get those out, we will go over those now. Nickel, phosphorus, and nickel. Alright guys, so when you're doing an orbital notation, you have to have the element symbol and a colon. Okay? So that's already 2 points right there. Okay? Element symbol and colon. Alright, so phosphorus is located here, and it is on the third row of the periodic table, so the electrons in its highest level are in the third primary energy level. Okay? Which means we're going to fill up all of the orbitals and primary energy levels before 3, and we'll, because P is over here in the P subsection actually, we'll fill up the S sublevel region, which is corresponds to these 2 columns here, and then we'll put 3 electrons in this P sublevel region where phosphorus is located. And so in our first primary energy level, 1 is the primary energy level corresponding to the rows on the periodic table. We have 2 electrons corresponding to, not the same as, but corresponding to the elements hydrogen and helium. And so there's 2 electrons. The first one always has an upspin, the second one always has a downspin. And then we get to the next primary energy level, because that's the whole first row, just 2 elements. The next energy level is here, and this is the S sublevel region, so we've got another S. And the second level, S sublevel. And then we've got 1 orbital in an S sublevel, and 2 electrons corresponding to, not the same as, but corresponding to lithium and beryllium. Now we're going to go over and fill up this section over here, starting with boron, and that's in the second primary level because it's in the second row, and the P sublevel region, so that's 2P, and there are 3 orbitals in the P subsection. And so we're going to fill that up, 1 in each box, following that school bus rule thing, and then come back and pair them up to fill it up. All right, so that gets us all the way over to neon at the end of that row. Now we're going to go to the next row, and that's 3S. Again, we're in the S sublevel region, corresponding to the position of sodium and magnesium. 2 electrons there, 1 up, 1 down. And now we're over here in 3P where phosphorus is located. You always have to show all 3 orbitals, even if some of them are empty. Okay? We have 3 atoms here, 1, 2, 3, that corresponds to, not the same as, but corresponds to putting 3 electrons in the P sublevel of the ground state phosphorus atom. And they put 1 in each box and stop. You do not pair them up. Okay? All right. So let's assign points for this, okay? You have to have a full box here, that's a point. A full box here, that's a point. 3 full boxes are joined together. A full box here, and 3 half full boxes. Okay? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 just for the boxes and the arrows that go in them. And plus the 2 over here for 11 so far. Then you have to have 1S under this box, 2S under this box, 2P under these 3 boxes, 3S under that one, and 3P under these. And so 11, 12, 13, 14, 15, 16 points total for this assignment. So the next problem then that you were assigned for homework was for nickel. And nickel's symbol is Ni. We're going to put a symbol here with a colon. Both of those are worth points, symbol and colon. Nickel is in the 4th row. So we have to fill up everything prior to the 4th primary energy level. So all of this gets filled up. Again, these are arrows, even though they look like half arrows or fish hooks or the number 1s and then the letter L's or something. I'm just making it it's kind of shorthanding it to make it go a little faster, okay, instead of having to draw out a full arrow. If you like full arrows, please do that. Some people do, that's fine. So that's everything up to and including argon now, because we've got 6 electrons now in that P sublevel region for the 3rd row or 3rd primary level. Now we're going to go to the next row here. Okay, and we're going to start over here with 4S, okay, and there's always just 1 orbital in an S sublevel region. S is just to have 1, and that's 2 electrons. And then we're going to go and drop back 1 primary level for these electrons represented by the position of these elements here. So instead of being in 4S, we're now going to drop back to 3D. So this is the S sublevel region, P, and then D sublevel region. And we drew that out yesterday. I'm looking for the notes to remind you. There it is. S, P, D, and F sublevel regions. Okay? All right, so we got 4S. Now we're going to go to 3D. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this section, which means we have to be able to put 10 electrons in 3D, which also means we have to have 5 orbitals, because you can have up to and only a maximum of 2 electrons per orbital. So once we put even 1 electron in here, there are 5 orbitals there, and you show them all, 2, 3, 4, and 5. And then counting the number of electrons we have, 1, 2, 3, 4, 5, 6, 7, 8. We're going to put 1 in each box, 2, 3, 4, 5, and then pair up as needed, 6, 7, and 8. Okay, so I've got 2 points here for nickel and the colon, for the symbol nickel and colon. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 points for that problem. And I think we add those together and we get 40 points total. Is that right? Do I need to recount them? Now that you've learned to do orbital notation, we're going to learn electron configurations from orbital notation. And once you've got orbital notation down, electron configurations are easy. Okay? So what I want to do is get out the stuff we did yesterday. So if you have your notes from yesterday in class, get that out. And we can see how this works. Here's all that work we did yesterday. And so I'm going to start with hydrogen here. This is all orbital notation. What we're doing today is electron configurations. Now, orbital notation has more information in it than electron configurations do. Electron configurations are kind of a shorthand of orbital notation. All right? Once you understand orbital notation, then once you see an electron configuration, you can infer the information from the orbital notation. Okay? But until you do the orbital notation, the thing about opposite spin and different orbitals wouldn't make sense. Electron configurations don't have all of that in there. For an electron configuration for hydrogen, we're going to write the element symbol just like we did with orbital notation. But instead of writing 1s kind of down below here, we're going to put 1s on the same line. And that's a number 1 and a lowercase letter s. Okay, make sure you're writing lower and uppercase letters. Okay? And all you have to do for the electron configuration is count all the electrons in that sublevel. Count all the electrons in that sublevel. Okay? All you have to do for electron configurations is count all the electrons in that sublevel. Well, there's only 1 electron in the sublevel here, S, for hydrogen. We're going to make that a superscript 1. And that's an electron configuration for hydrogen. Huh? Yeah, and it's a superscript on the S. Okay? For helium? Yeah. For lithium? No, I'll show you how to get lithium in a minute, okay? For helium, it's going to be capital H, little e. Remember to make all your letters clearly capitalized and clearly lowercase. Don't write a capital H and a smaller capital E and expect me to know that's what it is. Write lowercase e's. And then we're going to put number 1 for the primary energy level 1, S for the sublevel, and just count the electrons in that sublevel. Superscript 2. That's the electron configuration for helium. Okay? All right, now, someone just asked about lithium. So there's the symbol, there's the colon, capital L, little I, clearly 2 different letters, clearly a lowercase letter, clearly an uppercase letter. 1, I'm sorry, I made that a superscript for some unknown reason. Should be a lowercase letter S. That's not a superscript. S, and then a superscript 2 for the 2 electrons in that s sublevel. Okay? And then we've got electrons in 2s, so we're going to write 2s, and there's only one electron there, so it's 2s1. All right, so beryllium then. Well, I'll tell you what. Let's just stop a minute and let you guys do beryllium, and then I'll come back behind you and you'll see how you did. Okay, so write the electron configuration for beryllium, and we'll check it. You want to do it up here?
I will. I'll do it. I'll do it. I'll do it.
Who hasn't done one up here yet? You've done one.
Daisy has.
You haven't?
Daisy has not one.
Daisy hasn't? Come on in, Daisy.
You need help.
All right.
I like that.
Huh?
Just call me by my middle name.
Oh God.
I don't think that's the middle name. Boom. Got it. All right. Now I hope that doesn't seem hard. Okay. Are you being sarcastic?
Yes.
Okay. All right. All right. Well, let's skip over to carbon then. Why don't you do carbon real quick, and then I'll come back behind you and make sure you got it right, and then we'll skip over to things. Like I said, this seems to be a lot easier than the other. So do carbon. All right. So carbon has 2 electrons in 1s, so that's 1s2. 2 electrons in 2s, 2s2, and 2 electrons in 2p, 2p2. Does that make sense?
Like on the test, when you show that first, right? Notation.
Okay. The question is, on a test, will I show you the orbital notation, and from that allow you to write the electron configurations? And I would say probably not, because you're required to be able to do both orbital notation and electron configurations. Yeah.
So you may give us a problem and it might be like
I may say write orbital notation, electron configurations, and the shorthand version of electron configurations, which we haven't gotten to yet. Of all this stuff we did yesterday, we need to skip down and do one of these somewhere. You want to do argon? All right, there's argon. Let's do argon then. Argon. All right, guest teacher, come on.
Nope. Nope. I don't need extra credit. Please, class, be quiet. Okay, so. Oh, that's right.
No, it's once upon a time.
I'm going.
What's so funny?
My, this
You should have been listening.
I slept in this morning. You got me.
That was good, man.
No, it wasn't good. You got me.
Good job, Matthew.
Jerry's like, you should totally be a motivational.
Well, I can't see the rest of it, so I'm not.
No.
No, just kidding.
What?
Keep going. Keep going.
That is right. That's an S.
No. Then you didn't do yours right.
I did mine right. That right, Mr. Taylor?
Yes. Good job. You did it right. Congratulations.
Nope. Y'all are fake.
All right. Any questions about that? All right, then let me tell you about a different version of electron configurations. Okay? Now listen, This only applies to electron configurations. You cannot use this shorter version in orbital notation. You with me? Now, here's the caveat. On a test, quiz, homework, or any place else, you cannot use a shorter version of orbital notation, okay? Orbital notations have to be complete. However, because of the space available on your element cube project, we are going to let you do a shorter version of orbital notation on that only. You with me? You understand? Because if I see it anywhere else, I'm going to say, points gone, and you know how many points you get for each of those boxes, right?
Yes, 1.
Yeah, each box is 1. So if you don't have, if there's like 15 boxes and you don't have them all, that's 15 points you lose. Okay? All right, now, so on your element cube project, when you do your electron configurations, listen carefully. If you have elements up to and including neon, you are not allowed to use the shorter version of the electron configuration. Okay? And that's also true with orbital notation. Anything up to and including neon cannot be shortened, okay? But if you have any element larger than neon, you can use the shorter version of the electron configuration. And for the element cube project only, the shorter version of orbital notations, okay? So let me show you what is actually allowed as a shorter version of electron configurations. Now you got to be careful, because if a question asks you for the complete version, that's this. If a question asks you for the shorter version or doesn't specify, you're allowed to use the shorter version. So what I want to do is I want to go here and I want to look on the periodic table and I want to find this element and I want to find the next lowest noble gas. Okay, the next lowest noble gas.
Neon.
Now chlorine is not a noble gas.
Neon.
The noble gases are all in this column right here. Okay? So this is argon, that's a noble gas. The next lowest noble gas is neon. Okay? So what I want to do is replace everything that includes all the orbital notation or electron configurations for neon with just a symbol for neon. Let me show you how that works. First I'm going to do the neon electron configuration. That's 1s2, 2s2, 2p6. And if you notice, this part right here, all of this for neon, is the same as all of this part in argon. Does that make sense to everybody? All right? They're the same. So, the shorter version of argon would be written like this. You have to have the element symbol, and you have to have the colon. You know what? I say this over and over and over again. You have to have the symbol, you have to have the colon, and despite me saying it over and over and over again, there are going to be people on the test who are going to leave it off. You know, I hate that. I hate saying it over and over and over, making you do it the right way over and over again and still get it wrong on the test. What is the deal with that? Okay, I don't know. Anyway, no brain parts. Is that what it is? All right. So what I'm going to do is, since this part here corresponds to this, I'm going to be able to replace this part with a symbol for neon, but it has to be in a bracket. So it's bracket, neon, close bracket, and just write what's remaining. 3s2, 3p6. Okay? You can call that the noble gas configuration. Now let me tell you why we do that. The reason why we do that is because in chemistry, when there are chemical reactions going on, the only electrons that are involved in chemical reactions are those in this level right here. Okay? Whatever is the highest primary energy level. In this case, I have 2 sublevels in the highest primary level. I have a total of 8 electrons in the highest primary level. 6, that's a sublevel. 2, that's a sublevel. The primary level is 3, and in the third primary level, I've got a total of 8 electrons. It's only those outermost electrons in the highest primary energy level that are involved in chemical reactions. And so we shorthand the electron configurations because that's the only part that really does anything in a chemical reaction anyway. That make sense? Any questions?
Can you do another one like that?
Sure. Tell you what, let's do. Let me give you an assignment. You work with a neighbor, okay? Find a neighbor you can work with, and then we'll do the following. Let me find my list yesterday so we don't do the same thing over again. There we are. We did. All right, so here's the problem. We're going to write the orbital notation for, the electron configuration for, and noble gas electron configuration for chromium. This noble gas electron configuration is the shorthand version, okay, or the shorter version. That makes sense? And it's called the noble gas configuration because we put the noble gas in here. Got that? So write all three of those things and work with a neighbor, and then we'll see if how you did. Now let me be clear about something, since I've written chromium here in the sentence, just to be clear with everybody. When you do your element cube, you're going to write your chromium without a capital C, okay? And I'm trying to emphasize the fact that element names are not proper nouns, so you don't capitalize them automatically. You only capitalize them when they are the first word in a sentence or they're in a title or something, okay? So that's why I did not capitalize it here, because it's not the first word in the sentence, okay? And so when you do your element cube, you want to make sure you do your element on the front, that front cell, where the element symbol and number and all that go, without a capitalized element name. So you need to be careful, guys, that you understand, okay? Yesterday we did what's called orbital notation. Okay? Orbital notation looks like this. You need to know that's what the name is. If I ask you to do the orbital notation, you need to know that's what we're talking about here, orbital notation. If I ask you to do the complete electron configuration, this is what I'm talking about. Okay? If I ask you to do the noble gas or shorthand electron configuration, this is what I'm talking about. You need to know what those names mean. Okay? Now, if I don't tell you that you have to do a shorthand or full electron configuration, you're free to choose either this or this, except up to and including neon, you cannot do a shorthand version. That makes sense? You with me? All right. So now let's do the orbital notation, electron configuration, and noble gas configuration for chromium. Chromium symbol is Cr, and Cr is located right here. It's on the fourth row. So we're going to fill up all three primary energy levels up to 4. And we're going to partially fill up. We're going to fill up all of 4s and only partially fill up 3d. Okay. So 1s corresponding to hydrogen and helium, that's going to be full. 2s corresponding to lithium and beryllium, that's going to be completely full. 2p, that's corresponding to the positions of boron through neon. Going to fill those up one orbital at a time, or one electron per orbital, then pair them up. 3s corresponding to sodium and magnesium, 2 electrons. 3p. Now in this third row, there's a blank space right here. Don't try to fill in 3d yet, because it doesn't happen until you get to the next row. We do 3s and 3p. You just walk along the periodic table, number by number, like you're walking along the bricks on the yellow brick road or something, okay? All right, 3 orbitals in a p sublevel, 1 electron per box, and then come back and pair them up. And now we're in that fourth row where chromium's located. Now first we're going to start with potassium and calcium's positions. The electrons are not the same as the atoms, but they are corresponding to the positions of the electrons within these orbital notations. There's 2 electrons there. And then when we get to this section here, you have to drop back 1 primary energy level. Okay? And so instead of being 3d, because that is the d sublevel region, instead of being 4d, we're dropping back to 3d. Okay? So we're going to be at 3D now. And there are 5 orbitals in a D sublevel. And if you forgot how many orbitals, just count the atoms. Okay, if there are 5 atoms, if there are 6 atoms in a P sublevel region, you can only get 2 electrons per orbital. Well, that makes 3 orbitals, right? There are 10 electrons here, 10 atoms here, corresponding to 10 electrons in a D sublevel. That's 5 orbitals. And if you were to have an S sublevel, there are 14 here. That corresponds to 7. 1, 3, 5, 7. You see the pattern? No? 1, 3. Okay, I'm sorry. All right. So then chromium is number 1, 2, 3, 4. So we're going to put 1, 2, 3, 4 electrons, and there's chromium. Now, let me say this because you may see the electron configuration written differently somewhere. I want to explain it to you in a minute. I hope you're paying attention. Because while we're doing it this way in high school advanced level chemistry, in reality, this is not the actual orbital notation. What happens is, when you have 4 electrons in 4 orbitals in the D sublevel, because of where it is, it's actually in a 3rd primary level, it stabilizes the electron cloud to move one of these electrons from 4s down here. Now that's kind of a simplified way of even saying that. But that's what we really have. If we wanted the actual orbital notation for chromium, this second electron in 4s, the one that has a downward pointing arrow, would actually be upward pointing down here. And we'd have one electron here in one each of these boxes. Okay, now I know that seems kind of strange, but that's what actually happens. Okay, so if you see something different somewhere when you're working on your element cube, that's why. Okay, some of the things we do in here, we are simplifying them. Got it? All right. Yeah. So if we're going to do the full electron configuration, then it's just chromium, 1s and 2 electrons, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 1, 2, 3, 4, 4. Okay? The actual configuration is 4s1, 3d5, but it's, again, we're not doing that in here. Just letting you know, if you see it, that's what the problem is. Okay? Now, to shorthand this thing, we need to find the next lowest noble gas. So here's chromium. Now, pay attention closely, because I know there are people who are going to get this wrong on the test, and I'm trying my best to make sure you got it right. Count backwards from 24, 23, 22, 21, 20, 19, and you've reached the noble gas. That is the next lowest noble gas, number 18, argon. We're going to replace whatever is argon's electron configuration with just a symbol for argon in brackets to write the noble gas configuration. And argon's configuration goes from here to here. That's all argon right there. All right? All the elements in the last column on the right of the periodic table are called the noble gases. That's column 18 or 7A. I prefer 7A, okay, because it tells me something about the structure of the atom more than saying 18.
So if it was silver, we'd use krypton?
Silver is here, so the next lowest noble gas is krypton. That's exactly right. Okay? All right. Now, so what I want to do is write chromium. Again, listen, you've got to have that element symbol. You've got to have that colon. It's got to be there. To replace all this, I've got to put argon in brackets. You've got to have it in brackets. Parentheses are not good enough. It's got to be brackets. Okay? And then we just finish out the remainder of the electron configuration. 4s2, 3d4. All right, now what I'm going to do next is I'm going to assign a homework problem for you. Or actually, I'll give you 2. No, I'll give you 1, and then I'll require you to work on your element cube, because I'm going to tell you how to do your element cube project for this stuff, okay? All right, so let's say your homework is going to be to write orbital notation. I'm just going to write ON for orbital notation. And both electron configurations for, and since I was asked about silver earlier, let's do silver. I'm sorry, I wrote gold there. Yeah, that's silver. I'm sorry, gold is AU. Okay? So that's your homework tonight. And work to complete element cube.
So they're due tomorrow?
No, they're not due tomorrow because what we haven't gotten to yet is ion symbols. We'll do that tomorrow, and then they'll most likely be due on Friday then, okay? Yes.
So how many of those cubes? We be able to do 3 of those cubes by,
You have to do 2 cubes.
by Friday.
Every student is assigned 2 different elements. Okay?
Not cubes, my bad. Like the setup, the blocks.
Uh-huh.
So there's 1, 2, 3, 4, 5, 6 blocks. How many of those can we do ourselves without knowing? Like having to learn.
Okay, I'm going to show you that, so just bear with me, okay?
What we doing for homework?
This problem right here, and work on your element cube. All right, now let me show you some things about your element cube that's going to help you. All right, here's an example of an element cube. All right. All right, this element cube is asking you to do barium. Okay, so if I go down here to the middle and you know what? Some of the, what happened to the, let me find, oh, here we, let me do this. What I want to do is to have the same formatting. I think I must have deleted some of the formatting or something. Oh, bear with me. Pay attention, please. All right. So barium's element number is 56. So I want to replace that 1 with a 56. And as long as I just replace it, it's going to have the right formatting. Okay? Barium is BA. As long as I just highlight just the 8 and don't do anything else to it, it's going to have the right formatting. As long as I just replace this, we get barium.
Didn't you give us like a link? Wait, so when you open it?
I sent you one by email with an electronic version. I want you to do it electronically. Please listen carefully, and I'll probably answer all your questions. If not, there'll be time at the end, okay? If I have too many questions now, we won't get through this, and you need to know this. Okay, so bear with me. All right. Here are your test references, guys. This is what you all have a copy of this. So we're going to go down to the periodic table that has all of the atomic numbers. We're going to find barium. Well, this is barium down here, number 56. So we want this number right here. Okay? Now, I wouldn't suggest that you copy and paste like I'm doing unless you know how to make the formatting work out for you. Okay, there's a way to do it and get it right, and there's a way to mess it up. And if you don't know how to do it right, then don't copy and paste, just type. It's only, what, 6 or 7 numbers. It's not like it's all that bad. Okay? All right, and so there's the number. All right, now, in this box right here, below that name, it tells you what's required there. All right? It tells you have to have orbital notation. Okay? So then for barium, I want to do BA colon. Now, normally, you cannot write a shorthand version of the electron configuration for barium. I'm sorry, a shorthand version of the orbital notation for barium. Okay? Normally, you can't do that because it's not really allowed. It can be done for electron configurations, but not for orbital notation. So homework, quizzes, tests, you cannot write a shorthand version of orbital notation. But for the element cube, I'm going to let you do that. Okay? All right, let's go back to the periodic table here a minute.
Wait, so for the shorthand orbital notation, you do the same thing for shorthand electron configuration?
Pretty much. So there's barium right there, and the next lowest noble gas is xenon. Okay? So for the element cube only, okay, you can write barium, open colon, Xe for xenon, close colon, and now we're going to do, well, I'm sorry, I pressed the wrong button here. It's got to be colon, bracket, not that, okay? So Xe, all right? And now we're ready to do the orbital notation, okay? So on the periodic table, let me find my copy of the periodic table here. Then after xenon, we're in the 1, 2, 3, 4, 5, 6th row, and that's where we're going to find barium. Okay? So we're going to have 2 electrons in 6s. Now look right here. You see what I'm pointing to up here? There's a box right there with some arrows already in it. Okay? So I'm going to copy that. I'm going to click on it and copy it, and go down here and paste it, and there's the box. Well, guess what? I can just change that number 1 to 6, and boom, I've got 6s. Now, I need the next thing now, and if I need boxes that are empty, I click that one, and then boxes that have 1 arrow, I click that one and paste it. Okay. So I know I'm doing barium, and that's completed for barium, but let's just say I had a D sublevel, okay, and I want to have 4 electrons in a D sublevel, okay. Let me show you how that works. I can get my mouse to work here. Where's my mouse? Can't see the mouse on my screen. There it is. I saw it for a second. There it is. All right. So I need, if I want to do a P sublevel here, I'm going to copy that one. I need 4 orbitals. So I mean 4 electrons. So I'm going to leave a little bit of space to the D sublevel. Let's just say this is 5D, or 5P rather. Okay, 5P, and there's 2 electrons. That means I'm going to need 2 of these right here with the 1 electron to get 4 electrons. Copy it twice. And what I can, oh, I'm sorry, that's the wrong one, isn't it? Let's go back and use the 1. I just need the one with 1. Copy, paste, and then I just need to get rid of the number and the letter down here at the bottom on both of these. And there's 5P. I know barium doesn't have 5P. I'm using this as an example to show you how to do P's and D's and S. Everybody got with me? Yep. All right, I'm going to take those out so nobody's confused when they see it. I hope nobody's confused when they see it. Yep. You may go to the bathroom. All right, now. So, tonight, you should have your orbital notation and your electron configuration in your element cube. Okay? Got that? So that tomorrow, and in fact, you should have all your research done. You should have the element symbol and everything done. The only thing left to do tomorrow will be your ion symbols, which we'll cover in class. Got it? They're going to go in that same box down there just below that. But I'll show you that in a minute. Now, some of you have some really complex, larger elements with F sublevels. And we don't do that in this class. So here's how you're going to fix that. I'm going to send you an email today that will have the electron configuration, the orbital notation, not the electron configurations, but orbital notations for all of the larger elements. Okay? I'll send that to you. Got it? So from that orbital notation, excuse me, you should be able to figure out the electron configurations. Make sense? Yeah. And that'll make it easy for you if you have a really large element. You just have to construct it on the element cube. You don't have to know how to make it in the first place because it's not required that you do F sublevels in this class. Okay, now if you were taking an honors class, you have to do F sublevels. Okay, we don't do F sublevels in this class. Okay? Yes?
So research information goes in the...
Your research information, interesting stuff about elements goes here, and here, and here, and somewhat in here. Okay? All right? The specific information, orbital notation, electron configurations, and ion symbols go down here. And this right here is where you're going to put your element information that actually shows in the front of the periodic table. Okay? Now, listen. So then, when you have your element cube data done, you cut this out. Listen carefully. You leave these little ears. You see these little ears here on the side? Those stay there. You cut it out, leaving those there. You fold this up, and you put some glue on these ears, and you're going to glue it up into a square. There's even a video on my YouTube channel that shows you how to do that. Okay? Walks you through the process. Now, I have had students turn in element cubes where they got a whole lot of blank stuff here, okay? They put some information in there, but they don't fill it up, okay? That must mean you're a boring student, because the elements are not boring. There's plenty of information out there about the elements to fill up everything on this cube, okay? Well, boron even isn't boring, you know? Or, in fact, barium isn't boring either. Barium is named for Niels Bohr, who's a very important scientist in the history of the understanding of the way the atom is constructed, or the way it's made up, okay? Your attention. Now, the instructions on your element cube are supposed to say it, but just in case it doesn't, let's be clear. Your name goes right here above, right here above this fold, okay? If I don't have your name there, all your work is for naught, because I have no name for which to give a grade. Last name, first name, okay? I would rather you say, this cube created by, and your name. This cube created by. Here's why. These element cubes are going to be out here on our periodic table display in the hallway. I want students to be able to see who created that cube. If they want to see the information, if it's interesting to them, they should be able to take it down and read it and know who created it. You deserve credit, just like any information you put on the cube is deserving of credit. Now listen, I've said this before. I'm going to say it again, yes. Listen. Some of you are packing up, and I did not say it's time. Do not pack up until I say so. You're disrupting my class. I take that very seriously, because you're making it hard for other people to pay attention, and it's clear you're not. And I'm paid to teach. That's my job, okay? I take that seriously. I take your future seriously, and I teach, okay? All right. What was I going to talk about?
Somebody say it again.
Oh, credit. Whenever you put information on this cube that didn't come out of your own head, you have to give credit. If you look it up someplace, you have to give credit for where you looked it up. Okay? Well, you don't need a whole square for references. What I'd really rather you do is whatever information you have, put the reference right there immediately below it. Just make it in really small letters, enough that somebody could see it if they wanted to. In fact, I think in the example that I gave you on your element cube that worked for hydrogen, let me pull that up here and show you. Where is that? Here we go. Periodic properties, element cube blank. All right, so let's notice here. Please give me your attention. Okay, there is a credit I've given for this information in this block. Okay, it's justified to the right. It's in much smaller letters, but it gives credit for the information. You hear me? Malaysia, are you listening? Okay. All right, so make sure you give credit where credit is due. Look, I can tell by the way it's written, I can tell by the information that's there whether you've given credit or not. Give credit, okay? Otherwise, you're committing plagiarism. What happens if you commit plagiarism? Well, no, you don't go to jail, but you get a 0 for the grade, and your parents get a call. Now, I don't know about you, I'd rather take the 0 than have my parents get a call. Okay? But it's required by district policy or school policy that if you commit plagiarism, I give you a 0 for the assignment and I call your parents. You got it? All right. Now you can read your student handbook. It says so in there. Okay, listen. Let me say it again, please. Listen carefully. You can type in your element symbol and colon, and then you get to go over and find these blocks. to copy and paste in there to make your orbital notation. That make sense? So you don't have to write out orbital notation. You have to write it out on paper and then copy and paste it. It looks very neat and nice and tidy on your element cube. Okay? Just look at the video. Copy and paste. Copy and paste. Okay? Figure out what the orbital notation is first and then do it on here. Okay?